Welcome everybody, my name is Fabian Unruh from the HCI group of the University of Würzburg, and today I present you our work entitled Body and Time, Virtual Embodiment and its Effect on Time Perception. The work is authored by Fabian Unruh, David Vogel, Maximilian Landeck, Jean-Luc Lugrin and Marc Erich Latoschik. Let us first talk about virtual embodiment. Virtual embodiment can be defined as replacing your own physical body with a virtual one. Depending on the application, you might receive a virtual body with only hands, a cartoonish avatar, or a more realistic avatar. The nature of the virtual embodiment can have a major impact. It can influence our emotional response, the feeling of presence, and even change our behavior. But could virtual embodiment also influence our time perception? If we look at previous research, it might be possible since there seems to be a strong connection between one's own body and time perception. Previous work showed that emotional states can influence time perception, and similar brain regions are activated both in the perception of time and in the perception of bodily signals. Furthermore, people suffering from a psychiatric illness, such as depression, often experience a disturbance of body perception and time perception. To get a first indication whether virtual embodiment could have an impact on time perception, we previously let people wait 7.5 minutes in an empty room. People had to wait either in a real room or in a virtual replica of the room with or without a body. The results showed that the absence of an avatar is leading to a slower perceived passage of time. However, a waiting room scenario is very specific due to its nature, and there was no interaction with the environment. Typically, the activity itself is a driving factor in terms of how we perceive time. For example, if you are waiting for the train, you may feel that time passes very slowly. However, if you do something fun, like rafting, and don't think about time at all, time can pass subjectively faster. Using an active task to explore time perception in VR was already done by Zopf et al. In 2017. They let people do a short time interval estimation task where you first had to press a button. After a short delay, which was in the millisecond range, you would hear an auditory tone and had to estimate the time between pressing the button and the tone occurring. As embodiment conditions, they compared a sphere and a hand. However, the results revealed no significant difference between the sphere and the hand regarding the time estimation task. Compared to the previously showed waiting room study, Zopf et al. Used a tailored mixed reality setup. In their system, participants were still able to see their real body and the real environment. In a fully visually immersive system, however, using a VR headset, the participant's body is completely invisible and partially or fully replaced by a virtual body. Zopf et al. Also just compared a sphere with a hand without skin texture and measured embodiment with questionnaires developed for non-VR. To better assess the validity of previous findings, we investigated the influence of the degree of embodiment on time perception in an interactive scenario. In the high condition, people saw the controllers and had a full human body. In the medium condition, people saw the controllers and human hands. In the low condition, people only saw the controllers and no human body was present. As you can see, there is a lamp located on the table, and people had to press a button to turn it on. After they press the button, it changes its color and the lamp turns on after a short delay. People then had to estimate the delay between pressing the button and the lamp actually turning on. We performed a within subjects design with the 3 different degrees of embodiment as conditions. In total, we had 48 participants. Of these, 56.3% were female and the average age was 23.2 years. Our main result is that there was a significant difference in terms of how people subjectively perceive the passage of time. people had to rate how fast time subjectively passed on a visual analog scale ranging from extremely slow to extremely fast, 0 being extremely slow and 100 being extremely fast. The rating itself was given after each condition, when the subjects activated the lamp 45 times. In the low condition, in which people just saw the controllers in VR, people subjectively perceived the passage of time to be significantly slower compared to the medium condition, in which they received virtual hands as an addition. There was also a significant difference between the low condition and the high condition, in which people were represented with a full body holding controllers in their hands. People perceived a slower passage of time in the low condition compared to the high condition. These results are consistent with the initial evidence of our prior study, but now extend the context beyond waiting scenarios. Notably, in our prior work, we reported a faster passage of time for higher embodiment, while in this work we report a slower passage of time for lower embodiment. This difference in presentation is based on the interpretation of what we accept as a baseline condition and what we see as a derivation from that. Here we follow the recent congruence plausibility theory by Latoschik and Erich and conclude that the high and medium embodiment conditions generate less incongruencies. They seem to generate more embodiment cues congruent with expectations from the real world and the perception and cognition layers compared to the low embodiment condition. Hence, the high and medium embodiment conditions are expected to be more plausible and less deviating from a real-world experience. Since there was no significant difference between the high and medium conditions, it seems that both produce similar levels of incongruencies. However, the virtual embodiment could be adapted much closer to reality. People could be given a personalized and photorealistic avatar, which would, for example, increase the emotional response. In summary, the current study shows that the results initially found in a waiting scenario also occur in an interactive scenario. Hence, virtual embodiment seems to have an influence on time perception independent of the activity of participants. It also seems that body and time not only have a strong connection in general, but also in VR. Since the manipulation of virtual embodiment allows you to systematically and globally alter how you perceive your virtual body, it could potentially be used for research with people suffering from psychiatric illness. Thanks for your attention.